In this video, we're going to learn about standard deviation, and we're also going to talk about variance, which is a number that we will find on our way to calculating the standard deviation. So to start, standard deviation is a measure of how the values in a data set vary or deviate from the mean. So we've already talked about the mean and we know how to calculate it, and the mean is a measure of center. Standard deviation is a measure of spread. So it's basically telling us how spread out our data values are. So if we have a mean that's right there, and then let's just say we have some other values that are pretty close together, like that. If we had something like that, then our standard deviation of that data set would be really small because our values don't vary that much from the mean. They're pretty close to it. But let's say here's our mean, and then we have a data set, just to visualize this, that these numbers are kind of all over the place. And they're really far away from our mean. Then we would have a standard deviation that is bigger because those numbers are more spread out and they are further away from the mean. Okay, so our formula for calculating standard deviation is right here, and it's a lot of symbols, but we're just going to break this down. We'll first talk about what these symbols mean, and then when we actually calculate standard deviation, we're not just going to go straight through this formula. We'll break it down step by step. So if you need to refer back to this, that's absolutely okay. So this Greek letter sigma, it looks like a little O with a tail on it. That's the symbol that we're using to represent standard deviation. So it's kind of like a variable. It's just our symbol so that we don't have to write out standard deviation every time. This capital sigma represents the sum of a series of numbers. So you might have already seen that in math used to represent the sum, and you'll see that in the future. This x is just going to represent a value in our data set. So we've done tons of x and y tables, and now we're just going to have x in our table, and that just represents the values. Then we have x bar. So we pronounce this as x bar, and it's literally just an x with a little bar over the top of it, and that's going to be our symbol to represent the mean of the data set. And then our last one, we have n, and n is just the number of values in the data set. So when we calculate standard deviation, we are going to, I'm just going to read this out, take the square root of the sum of x, which is our values, minus x bar, which is our mean, all of that squared, and then divide that by the number of values in the data set. So let's go to our first example, and this table is just here to organize the information for you. So it breaks it down step by step, keeps your information organized, and as you are doing your own problems, I would suggest maybe using a table like this, setting something up like that on your own paper so that you just can keep track of everything as you're working to calculate the standard deviation, because it is a lot of steps. So the first thing we do is calculate the mean, and we know how to do that, but as a reminder, we just add up all of our values. So here's the values, here's our data set. We would add up these numbers and divide by however many we have. So on this one, we would do 12.6 plus 15.1 plus 11.2 plus 17.9 plus 18.2. And then we need to take all of that and divide by, we have 1, 2, 3, 4, 5 numbers in this set, so 5. When we do that, we get 15, which is why this next column, x bar, is full of 15 because that is our mean. And the mean is the same, so each of these boxes is going to have the same number in it. They're all 15. Then on to step 2. So for step 2, we need to find the difference between the data value and the mean. And difference, remember, means we are subtracting between each value and the mean. So this is set up nicely for us in our table, and it's written right here what we're doing. We're taking x and subtracting x bar. So the value minus the mean, 12.6 minus 15 gets us negative 2.4. 15.1 minus 15 gets us 0.1. 11.2 minus 15 is negative 3.8. 17.9 minus 15 equals 2.9, and 18.2 minus 15 equals 3.2. Okay, so that is step 2. Step 3 is then to square each difference. So all of these values that we just got, we need to square them. The important thing, and it's written right here, is this is the part that you're going to type into a calculator. You need to make sure that you put each of these in parentheses before you square them. The reason for that is with our negative numbers, if we don't have it, then it will give us a negative number, and all of these numbers should be positive. Okay, so parentheses, negative 2.4 squared gives us that. Parentheses 0.1 squared gives us 0.01. Negative 3.8 squared equals 14.44. 2.9 squared equals 8.41. And 3.2 squared equals 10.24. So that is step 3, just squaring all those values. Remember your parentheses. Step 4. Now we are going to find the mean of those numbers that we just got. So we know the mean. We add up all the numbers, divide by the number that we have. So on this one, we need to find the sum of these 5 numbers. So 5.76 plus 0.01 plus 14.44 plus 8.41 plus 10.24 divided by 5, because we still have 5 values, and that gives us 7.772. So when we get that number, that is actually called our variance. And you might get some problems that ask you to solve for the variance. So when it says that, then you just stop here. You found the variance. Our variance on this problem is 7.772, and that's it. Then the last step for standard deviation, we take the square root of the mean of the squares to find the standard deviation. But that's just saying take the square root of the variance. So we got our variance, 7.772. We take the square root of that, and that gives us approximately 2.79 for our standard deviation. So final answer, standard deviation, is right there. All you do is take the square root of the variance. All right, so I'm going to scroll down to our second example, and we're going to do the exact same process, except now we have a new data set, and then it asks us a couple questions over here. So I am going to go back up to step 1 and remind us that step 1 is to just calculate the mean. So go ahead and try that for these values, 13.4 plus 11.7 plus 18.3 plus 14.8 plus 14.3, and then divide by, we still have 5 values here, so you're going to divide by 5 again. So we should get 72.5 divided by 5. So for our mean, we get 14.5. So I'm going to write 14.5 in every box under our X bar for our mean. Then X minus X bar is our step 2. So we are just taking each value and subtracting the mean. So we have 13.4 minus 14.5, and we get negative 1.1. The next one we have 11.7 minus 14.5, and we get negative 2.8. 18.3 minus 14.5, we get 3.8. 14.8 minus 14.5 gives us 0.3, and 14.3 minus 14.5 is negative 0.2. Then, step 3, we're going to square each difference. So those numbers that we just got, we need to square them. So negative 1.1 squared gives us 1.21. Negative 2.8 in parentheses squared is 7.84. 3.8 squared is 14.44. 0.3 squared, 0.09. And negative 0.2 in parentheses squared is 0.04. So remember, we want all of these numbers to be positive, and they all are because we put parentheses around. And at this point, we shouldn't be rounding. So write it out exactly as your calculator shows it. Now we go on to step 4. So we need to find the mean of those numbers that we just had. So add these up and divide by 5. So we have 1.21 plus 7.84 plus 14.44 plus 0.09 plus 0.04 is 23.62. And then if we go down step 4, remember this is finding our variance. So we take that number we just got, 23.62, divide that by 5 because we had 5 values that we added together. And we get 4.724. Then our last step is finding our actual standard deviation. So we got the variance, we just need to take the square root of that. The square root of 4.724 is 2.17, and we'll just round it to that. So 2.17 approximately. And pay attention if a question asks you to round it to a certain number. Otherwise, we'll just go to the hundredths place. So these questions over here, question 1 says, which set of data has a greater standard of deviation? So we're just going to compare. Top one was 2.79, the bottom one was 2.17. So set 1 has a greater standard deviation. The data set with the larger standard of deviation has a larger, more spread out range of values. If many of the data values are close to the mean, then the data would have a relatively small standard deviation. This would tell you that the data is not very spread out, and that's what we were talking about at the beginning. But now we can see it in our actual standard deviation values. Okay, so we have a couple more examples that you're going to try on your own. Find the standard deviation by filling in the table. So you're going to fill out these tables with set 1 and then set 2. Find the standard deviation of each one, and then you're going to compare them. Which set has a greater standard deviation? And it might be a good idea at the beginning, once you figure out the mean, go ahead and look back at these sets of data and see if you can estimate which one's going to have the higher standard deviation, which one looks like the values are further away from the mean overall. And just try these two examples on your own, and then that is it for today.